Welcome to our screencast about TacZombie. My name is Lars Eckervogt and I'm here with my colleagues Stefan Juncker.
Hi.
And Manuel Rieke.
Hi.
Today we're going to present our game TacZombie, which we developed in the course Modern Programming Language at the University of Applied Science in Constance. The course was offered by Professor Dr. Boger and in the winter semester 2013-2014. First, we're going to show you something about the game principle, then we will mention everything which is worth the word. We will show you some tests that we wrote, a quick demo, and finally a summary about the whole project. The game TacZombie is a tactical clone from the game Pac-Man. I hope every one of you knows that game. And the game TacZombie is round-based. It has 2 players, 1 human player and 1 zombie player. Both can have multiple tokens. The goal of this game for the human is to survive and collect all the coins, and for the zombie to stop the human from collecting coins and kill him multiple times, at least so much times as life he has. The map is a Pac-Man-like map. You will see that later in the demo. And of course, in the background you see the map.
Now I will give you a quick overview about our structure. Here you can see that our project is subdivided into 3 sub-projects, which you can see on the right side of this figure. It's model, GUI, and vui. These are exactly the same project name as they were in our IDE. As you can see, we use MVC pattern. Also, which is important to know, our program uses client-server architecture. This client-server architecture should the clients and the servers should interact via WebSockets. The clients in our games are the web UI, which you can see here, the graphical user interface, which you can see here, and the textual user interface. The server part of our program is also in the project web user interface controllers, because we use for the web user interface the PlayFramework, and this framework also implements WebSockets on the fly. Also here you can see only the controller, the server controller, holds the model, and also only the controller will update this controller. The model, yeah. And all clients will only get the updates via WebSockets and JSON format from this controller. Now something more about the controller. As I already mentioned, it managed the WebSocket connections and it managed the game. So I will click on this. Okay, das funktioniert nicht.
Kannst du aber reinschwitchen. Hast du mal einen Hintergrund?
Okay, here you can see on the right side the 3 views, and they will interact with the web server via string commands. And the web server will just evaluate these commands and execute the command if it's valid, and also change the game if it's a valid command. And this changed game will be transformed into a JSON string and will be resent to the view, and this view will transform this into graphical data. Okay. Yeah.
Okay, in the previous slide you saw that the application acts on the model. I'm going to explain to you what the model is about. We tried, or basically we did, use the traits to form a type hierarchy, which can later be easily used with the match case pattern Scala offers. On the bottom you see the case classes, which are instantiated and acted on. You see the human token, the zombie token, which are player tokens. Then we have the coin and power up, which are collectibles. And we have a wall, which belongs to a completely other object, static game object. I will explain further what this all means. Basically, we make separations between objects that can move or can interact with other objects and objects that are just static. But for all of the objects to have certain methods, implementation in common, and certain fields, we use the game object trait, which can in Scala also implement things, unlike an abstract class, which you could know from Java. The model contains the game's logic. The model doesn't result in an executable file like the application or the different UI stuff do, but instead the model is used by the application to evaluate a game's result or a command that is executed on the game. The model is type safe through the match case pattern and is therefore also easily extensible, because if you add another object later, if we decide to add more tokens or a different type of tokens, like maybe a dwarf, you can just add a different match case or a case to the match. Our model is scalable because we use containers. That means we could add more players later, or more tokens, or bigger fields, or whatever comes to our minds. As this was a class to study the language Scala, I will show some example code. This is something we used to log. We used the trait pattern to get a logger to every other trait or class we wanted it to have. If you extend this logger with another class or trait, you automatically have the object logger, which acts as a singleton for your object, and you can easily use the plus is, I don't know how to say that correct, but the plus equal to log data into your logger, and you can use another method which you can't see here to get the data back later. This is a very cool thing. You can just extend it and your object automatically can log to a system-wide logger. Another example is the game field cell. We have talked about game objects, which you can see are stored in a game field cell. And for easy handling, we can use the game objects, which is a set of game objects, and we can use the collect methods on them, which is a pretty useful method. It includes a match case, and it is only a partial function, so you don't have to match every case. You just match the cases you want, and you can form subsets of your existing sets, like this.
So now I'm going to tell you a little bit more about the views. Manu already told you a lot about it. We have the web user interface, which is hosted as a Scala application, and a textual user interface, which is a Scala terminal application, and the graphical user interface, which we implemented with Swing. They all communicate through WebSockets. The Play application is communicating through WebSockets, and on the client side, that means the web browser, it's using JavaScript to parse the JSON back to the HTML output, the HTML output. The textual user interface and the graphical user interface use an external library which we found, which is really neat. It's stable and it works out of the box. It's called just WS. Basically it does the same as the web user interface JavaScript code. To transform our objects into JSON, well, actually, we were using JSON as a transport format, and to transform our objects into JSON, we used Spray JSON, which is part of IO Spray.
The controller.
Yeah, the controller on the textual user and graphical user interface is basically the same, has the same functionality. Here we finally were the only group which used dependency injection in the project. I guess in this part of the presentation our professor is happy because we are the only group he used it, and we were thinking a lot about it, where we could actually use it. And yeah, finally in the end we used it to have one executable for the GUI and the TUI, and yeah, with the injection we provide the actually user interface to get started. We can see we made a class UI module, and this UI module binds either the TUI or the GUI to the interface or trait iView, and the rest is just yeah, opening it and run it blocking. And if we don't want to restart it, we would end the program. If you want to restart it, we would restart it in the while loop.
Okay, now we come to implicit conversions. We used the implicit conversion at several times, just to mostly to get a better, that it looks better, and
Syntactic sugar.
yeah, it's called syntactic sugar, and also to make it easier to use the code. So often in this example you can see we extended int tuple, int tuple really often, and we just did an implicit conversion on that we can just call the method left of, right of, above of, and below of on a tuple. So everywhere in the code, when we want to know what is right of a tuple or coordinate, we just can call this method, and in the code it all looks like a own domain-specific language. Okay. We also used, or not just used, higher order function. Many functions in the container classes do already use higher order function. We also created a higher order function. Actually, it was in a test. In this test, we just look onto coordinate and want to check the upper left neighbors, and if they are really bigger than the coordinate we want to check, just if this should check the call is upper left of. So we defined first of all the parameter chord, and then a y coordinate and a function for this, which should transform two ints to an int, and also for the x coordinate we will do the same with the second function. And here you can see the call of it. We take the x coordinate 10 and have the function minus. Minus is defined as that the first value minus the second value should subtract. And as you can see here, that minus would be called there, that it would make 10 minus I, which is incremented here. So we'll do 25 times the y coordinate minus the variable I. And the same is here for the second function. Yeah. Okay.
Of course, we also wrote tests to test our game or to test the methods. The main focus went to the model, of course, because it contains all the game logic. And I am actually going to show you some tests we did. We have a coverage report as HTML. We wrote 200 fully automated tests. Let's run them. I prepared something. We used the Scala build tool, and this is a command chain which cleans the project. Then it runs the Scala code coverage tool test, and then it merges all the sub-projects reports together. Let's run this. While this runs, we can take a look at some tests because it's boring to just look at a cursor. Okay. We have some test objects. This is hard work and boring work you have to do for manual testing. I wish this could be automated. Here you see a test map. It's a very easy one, it's just a straight line. But you need easy objects like this so you can act, or you can basically know what happens when you do the moves. And let's look at the test for the game field cell. They are all called specs because we used the specs 2 test framework. Here you can see we used all the contains methods. Now it gets a little bit more interesting. Here you can actually see what happens when you move a living human token to a cell with a power up. We simply test if the human has collected the power up, and he has to have the power up time, of course. So we basically just simulate what the player does in the later game. Let's see if our test already went through. It's still going. It's a pretty big project. We haven't expected it to be that big in the beginning, but we are glad it went like that.
Awesome.
Okay, I think this will take a little bit longer. Let me show you one more test, which also shows an interesting things you can do with Scala. Let's look at the game object specs. This could be written a little bit more readable, but in the tests we didn't want that. We didn't want to have the syntactical sugar in here. We just wanted to have straightforward tests. For example, you could just skip the points here. And you can just read it like the living human token is visited by a living human token, which makes not a lot of sense. But in the actual game, you can just run through another living human token, so we have to test all these cases. And actually, they turned out to show some bugs we would have never found by just testing it.
Implementing.
Okay, the tests are running. I think they're done. All 200 tests passed. Let's look at the result in the browser. I prepared this, of course. We have 100% code coverage, as I mentioned earlier. This was very important to us because this is what happens when you play in the background. If it would fail here, you could possibly walk onto a zombie with a power up and die, and you don't want that. Okay, so we see everything's working fine. With the different UIs and controllers, it's a little bit harder to test them. We basically did that by hand and by eyes because we just tested what it looks like. And the communication between the controller and the UI. Okay, this was it. You saw our tests. We have also generated standalone applications for the server and web UI. We did this by SBT. You can see the commands here. I don't have to read them out for you. We provided we can by this provide packages so you don't have to check out our source code and you can just download it and run it. I have prepared that too. We are actually going to see the game in action. Okay. Let's start the server first. You can see the structure. We have the TacZombie client jar here, which is the client package. It contains GUI and TUI. We have the WI. It contains the server, including the play library. We can just start it by running the binary provided. We actually have to run the shell script. Now our server starts up. We have now the possibility to use the browser to view our web UI. We are on the local computer. We could also connect from the internet. Maybe we could even have a network game, which Lars is connecting now on the local computer. Lars, do you want to be the human?
Yes.
Okay, move it. Okay, we can see Lars is playing with me on his laptop. Well, basically we have to switch to the next player. We have to be fair. We could also switch back and forth because you can play on the same computer with 2 players. Let's see, I am the zombie, I have to hunt him now. Okay. You can see he's moving towards the power up. Oh, now he's switched to the other token. You can also do that during one round. We are playing 4 humans against 2 zombies.
Well, there you can see the tactical aspect.
Yeah, we have to plan every move. It's not like the original Pac-Man, you know. You actually have to think about every step you make. All these parameters you see, like moves remaining, current player, and such, they are transferred from the model on the controller through JSON to the UI. And now we can I will show you connecting with the text UI. You can see I can start it with the TacZombie client jar. And the cool thing about our implementation is you can use all the UIs concurrently. They act on the same server, so there's one game state on the server and you can connect. Now you can see.
Show the other, show that it's the same.
Okay, you can see our game state. It's not a fresh game. You see it has already been played.
Yeah,
and now we will connect the GUI too.
Okay, yeah, you can see it.
This is the default case. You could also connect to another host. Okay, and now I'm going to show you that if we play,
Now I'm gonna move.
if Lars is moving on the other laptop,
But I'm actually gonna switch to the other token on the left side so you see it, oder? Wait a second.
we can see it.
Yeah, but this one on the left, up here.
I can
you
see
on
everything.
both now.
Oh yeah.
You can see the
Update.
both UIs are updating, and I'm not touching a single key.
Now it's your turn, Stefan.
Now I am.
You can kill.
I got
Oh.
Okay, I think that is enough gameplay. We don't want to collect all these coins. Let's go back to the presentation.
So now we're at the end of our presentation, and we want to just give you a short summary or resume about the whole project and about Scala and what we achieved in that project. We implemented a GUI, a TUI, and a WUI, and compared to other groups, our user interfaces are usable at the same time on the same model. Our model is fully automated tested, our controller is automated tested. We organized everything in a nice SPT project. Yeah. And
project.
yeah, what we can say after all that work is that Scala is really awesome. We really got to know some nice features, and I guess no one of us is really like in the mood to go back to Java. And about the UIs, we think Swing is okay, and Scala FX really lacks in support and useful examples to actually implement your own GUI. Thank you for your attention, and we
We hope.
We hope you like the game.
Yeah.